the reproduction and growth in plants. So with this, we would be dealing with acids, bases, and salts. Acids, bases, and salts. Our lesson today will be focused on only acid, what they are, and how we would know whether there's an acid or not. I'm hoping you all know what acids are, and we have some that are most common, are very common to everyone, and those are not too common. And there are some that are very common that we know, but we have no idea they are acids. So today we would look at all the types of acids that are made available and how we identify them. So to start, great scientists have defined or they have various ways that they define acids. In integrated science books, you notice that it's been limited to only two scientists who define acids. By those doing elective chemistry, you would also find out that there are actually three people who define acid. Now, all the definitions seem slightly different, but they carry the same concept. We'll take them one after the other and know how each scientist define an acid, so that you know. Now, the most simplest person that define an acid is Bronsted Lowry, or Larry. Now, he defined an acid as a proton donor or hydrogen ion donor. In other words, he defined an acid as a substance that donates proton or donates hydrogen ions. A simple definition that you can have. Then another man also defined an acid. Arrhenius also defined an acid as any compound which, when dissolved in an aqueous solution, example water, forms hydrogen ion as the only positive charge ions. He defined an acid as any compound which, when dissolved in an aqueous solution, forms hydrogen ions as the only positive charged ions. Now, these two definitions, one looks simpler than the other. The first one, proton donor. Now, this Arrhenius definition that looks lengthy. It means the same thing as that of Brown-Solari, the same thing. Because in the end, they all donate proton to hydrogen ions. Then the last man, Lewis. Lewis also sat down and defined an acid as an electron pair acceptor. An electron pair acceptor to form a coordinate covalent bond. An electron pair acceptor. Now, the electron pair acceptor means that they are donating their proton to hydrogen ions. Now, these are examples to show the reaction that is formed when an acid in an aqueous solution dissociates or ionize to give out or donate these protons. Example number one. Now, it will be possible that some of you with the phone, you might not see the equation, some of the equations very well. So I would be Now this HCl in an aqueous solution will ionize to give you hydrogen ions and chlorine ions. So what you can see here, it is giving out or giving you hydrogen ions when dissolved in an aqueous solution. Then example number 2, you have NHO3. HNO3. That is triazonitrate 5 acid. Now, when this also occurs, when it ionizes, you have it releasing hydrogen ions, then you have nitrate ions. Another example is H2SO4, that is sulfuric acid. H2SO4, sulfuric acid. Now, it also gives out um, two atoms of hydrogen, then that of sulfate. So you have it's the same thing releasing or giving out hydrogen ions or protons. So in an event of an acid being formed, always protons are donated and hydrogen ions are also donated. The same concept. Now let's look at some examples of the acids. We've already looked at it in the equations that we had. Okay, so the first one, hydrochloric acid. That is HCl. You've already seen that one. You have tetraazosulfate 6 acid. That is sulfuric acid, H2SO4. You have triazonitrate 5 acid, as I made mention, HNO3. You have tetraazophosphate 5 acid, that is H3PO4. They are all types of acids, whether they are weak acids or strong acids. They are all types of acids or compounds that are acidic in nature. Then you have triazocarbonate 4 acid, H2CO3. Triazocarbonate 4 acid. They are all kinds of acid. Then we have ethanoic acid. We have ethanoic acid, CH3COOH. CH3COOH. They are all types of acids. Now, in a later or further discussion, we'll look at whether these ones, which type of acid can we classify them under. But I need you to understand these are acidic compounds that are found. Okay. Now, what you need to remember about all these acidic compounds is that when they are dissolved in an aqueous solution, example water, they release these protons, they release these hydrogen ions in this aqueous solution. So you see that after they are dissolved in water, the HHHHH are released. Whether one is released or all of them is released. We understand also that when we are dealing with basicity of an acid, we'll look at how that occurs and how it affects the acid in one way or the other. Now let's look at how, Ben, if you have any question, you can ask, raise up your hands. You can also send me a personal message via the chat button. I would attend to you. Okay, so let's look at the strength and concentration of an acid. What do we say the strength of an acid is? What do we say the concentration of an acid is? How strong is an acid and how weak is an acid, how concentrated is an acid, and how less concentrated an acid is. You just need to understand how they are. Now, the first thing that we need to know is strong acid. Looking at the strength of an acid, strong acids. Now, these acids, they are defined as acids that when they are dissolved in an aqueous solution, they ionize completely, they dissociate. In other words, in layman terms, they dissolve completely to release protons or hydrogen ions. They dissolve completely. That is that is one way to define a strong acid. It dissolves completely, or dissociates completely, or ionizes completely in an aqueous solution to release protons or hydrogen ions. So examples that we have are hydrochloric acid, sulfuric acid, and triazonitrate 5 acid. Sorry, these are examples of acids that are strong in nature. They ionize completely in an aqueous solution to release hydrogen ions or protons. Now, the second aspect of the strength of an acid is the weak acid. The weak acid. Now, as compared to the strong acid, is the opposite of the strong acid, in that these are acids that they dissociate or ionize partially in an aqueous solution to release protons. Now, when these protons are released, there's difficulty in releasing these protons, or only a few amount of these protons or hydrogen ions are released. So with a weak acid, you have them as they ionize partially. Strong acid, they ionize completely in an aqueous solution. That is how just a simple way you can put them. Differentiate between, give difference between strong acid and weak acid. Strong acid dissociates completely in an aqueous solution. Weak acid dissociates or ionizes partially in an aqueous solution. Examples of weak acid is ethanoic acid. So basically, it deals with this acid with a lot of replaceable hydrogen ions, a lot of hydrogen atoms in them. Okay, so now we've established the strength of an acid. Now we look at the concentration of these acids. Now, how would you determine whether an acid is concentrated or not concentrated? Now we put these two into two groups. We have concentrated acids and 2 diluted acid. So there's a reaction between of the ethanoic acid. Sorry, I forgot to highlight that out. So at the point of dissociation, when you see the ethanoic acid is CH3COOH. You have 4 hydrogen atoms here. Now, at the point of dissociation, you see that it has given off 1 hydrogen ion and atom or ion, then the rest are there. So it just give out just a few, because it's finding difficult to release all the protons. Okay, so a concentrated acid. When we say an acid is concentrated, now it means that it contains more of an acid in a given volume of a solution. So let's say, let me use a common aspect in our life. You are doing Gary soakings. Then by mistake, you pour a lot of sugar inside. At that point, your Gary mixture is concentrated with a lot of sugar. That Gary soakings that you are doing is concentrated with a lot of sugar because you poured more inside. So over here, it contains more of an acid in a given volume of a solution. That is a concentrated acid. Now, the point where you see that your Garrisokins is so sweet, what do? You add water. So, when you are adding water, you are reducing the concentration of that sugar solution, sugar in your mixture. Now, in doing so, we refer to that as you are diluting your solution or your Garrisokins. So that gives us a diluted or dilute acid, which contains less of the acid in a given volume of a solution. So the moment the solution is more than the acid is diluted. So these are two different things you need to know about the concentration of an acid. When it's concentrated, it has more of the acid in a given solution, and when it's diluted, the solution is more than the acid itself. So strength of an acid, concentration of an acid deals with strong acids, weak acids, concentrated acids, and diluted acid. If there's any question, I'm still up for them. Okay. So in the absence of any, we'll look at the properties of an acid. How will we know this? How an acid looks like, and what an acid does? Properties of an acid. Properties of an acid. Now I'll give you the physical properties of an acid. Line up. I think the first four. Then you look at the reactions of an acid. So in a way, chemical properties of an acid. So the first four will tell you. Okay, the first five will tell you. 5 or 6 will tell you the physical properties of an acid. You can see with your eyes, you can taste with your tongue, you can even smell. Then the rest will give you reactions of an acid. So the first property of an acid is that it has a sour taste. On the tongue, it tastes sour. 2, acids are soluble in water. And they can easily dissolve in water. Acids are soluble in water. 3, they have pH less than 7. So on a pH scale or on a pH indicator, pH meter, acids have pH less than 7. So from 1 to 6, 7 being the neutral point. So from 1 to 6 or from 0.16 determines how acidic a substance is. Then number 4, they turn blue litmus paper red. They turn blue litmus paper red. Another important property of an acid is that acids are electrolytes. Now, electrolytes are substances that conduct electricity. Electrolytes are substances that conduct electricity. So they are strong electrolytes. They conduct electricity easily. Then acids are corrosive when concentrated. Acids are corrosive when concentrated. So when they are concentrated, they have more of the acid than a given solution. They are very corrosive. Now, at the point where they get in contact with your skin, they can corrode off your skin and it will deform your face. Now, one example of a very concentrated acid is sulfuric acid. Now, this acid is the one found in the car batteries. The acid in the car battery, that is what we call sulfuric acid. Very concentrated. So when your dad is working on his car and he asks you to go back, you should understand. Because or not when you're not being very careful, you can get hurt. Okay, now let's look at the reactions of an acid, being the property of an acid. So one, acid reacts with a substance called base. It reacts with a substance called base to form salt and water only. Acids react with bases to form salt and water only. Now, this phenomenon is also referred to as the neutralization reaction. Acid reacting with bases to form salt and water only. Now, when they form um, any other substance aside the salt and water, it is not a neutralization reaction. When we look at those deep when we are progressing. So look at a reaction between an acid and a base that would form salt and water only. Now you have a common one, HCl, hydrochloric acid, then a common base, sodium hydroxide, NaOH. Now when these two are put together in a reaction, you find out that the sodium will go for the chlorine, then the hydrogen will go for the OH ions. Then in the reaction, you'd have forming NaCl, that is sodium chloride. That is a common salt, the salt that we use at home. The one that is found at is the sea. So NaCl, that is common salt, sodium chloride, then plus water. So these are the two reactants that you get from the product. The products that you get from the reactants, that is the HCl and the NaOH. So this is an example of a reaction between an acid and a base. Okay, so let's look at the next reaction. Acids react with carbonates or bicarbonates to release carbon dioxide gas. Acids react with carbonates or bicarbonate to release carbon dioxide gas. Now, these carbonates or bicarbonates, they are all compounds of carbon. So they are normally CO2, CO3, CO4, CO2, CO3, 4, or a compound attached to this CO4, CO3. So when an acid reacts with any compound that contains this carbonate or bicarbonate, carbon dioxide is released in the process. Let's look at how this reaction looks like. Example, you have NaCl, that is 2 moles of NaCl plus calcium carbonate. So you see that calcium, the element calcium is there, then CO3 carbonate is there. So you can know that this one is a carbonate or a bicarbonate compound. And HCl is an acid. So the moment the two react with each other, then calcium chloride is released. It's also a form salt. Then water is released, H2O, then plus CO2. That is the carbon dioxide that has been released. So when you see a reaction like this, you should know that an acid has reacted with a carbonate or a bicarbonate compound. Now, what you see there is a balanced equation. Would, if time permits in later studies, I might be teaching how to balance equations. Then the last reaction that we have, or the last property of an acid, is that acid reacts with some metals to give hydrogen gas or to release hydrogen gas. Now I use the word metals because not all metals. There's some metal that when they react with acids, there's no reaction. But there are some metals when they undergo this activity series, a list of metals, when they react with an acid, then they give off hydrogen gas. A practical example of this acid is zinc. Zinc. Now, when this zinc reacts with an acid, sodium is also part, when they react with an acid, you notice that you have zinc chloride, salt, then um, hydrogen gas being released, H2 is being released. So in every way that this acid reacts with metals like zinc, sodium, potassium, they give off a form of salt, then the hydrogen gas is released. So this is an equation for you to know how this takes place. Okay, now since we've looked at hydrogen gas being released, we'll look at how hydrogen gas is being prepared in the laboratory. We'll look at how this hydrogen gas is being prepared in a laboratory. Now, that is what you see on your right is a setup for the hydrogen, how to prepare hydrogen in the lab. Now, let me list the apparatus that you need. So one, you need a flat bottom flask. Two, you need a tester funnel. Three, you need a delivery tube. Four, you need a glass jar. They are all on the, I'm just mentioning them. Five, you need a water trough. Six, you need a beehive. Seven, you need water. Then you need the two components that will enable the gas to be released as the hydrochloric acid and the zinc, or if any other metal that you can have as magnesium, but preferably using the zinc. Now what happens is that the hydrochloric acid is being poured down into through the tester funnel into the bottom round, but the flat bottom flask, which contains in which the zinc is being found. Now at the point what that is happening, that when the reaction is taking place, the gas that is being produced from this reaction between an acid and a metal passes through the delivery tube. If you notice on the diagram, you see that there's a cork that holds the flat bottom flask in place so that the gas will not escape. So it passes through the delivery tube, then through the beehive, then the gas is collected in the gas jar. So when the acid reacts with the metal, then hydrogen gas is produced. So it's collected over water as shown in the diagram that you're having. So the hydrogen gas is produced, it's collected in the gas jar. So that's the equation that you have compared to the other one. So you have zinc and hydrochloric acid giving you zinc chloride and hydrogen gas. And the same thing for magnesium too. You have the same reaction. Now what happens, how would you know that the gas has been collected is hydrogen gas? Now you take off the gas jar, then you pass or you insert a glowing splint. Let's say you take a matches and you on the light. So the light is a glowing splint. The moment it's taken close or placed in the gas jar, and there's a pop sound that comes out that or confirms or detects the presence of hydrogen gas. If you don't have a pop sound when you send close to the gas a glowing splint, that is not hydrogen gas. So when a glowing splint is inserted into the gas, that is the gas jar, it gives a pop sound which confirms the presence of the hydrogen gas. So this is how hydrogen gas is produced in the lab. And let's look at properties of this hydrogen or this hydrogen gas. The physical properties of it, then we'll look at the chemical properties of it. So one, hydrogen gas is colorless and odorless. Colorless and odorless. Two, it is not soluble in water, does not dissolve or dissociate in water. Then 3, it is less dense than air. That is, it's not heavy in air. Less dense, meaning that the air is heavier than the gas. Now let's look at the chemical properties of the hydrogen gas. Chemically, how will you know the combination of this gas? 1, it does not support combustion. It does not support burning, so it wouldn't support things to burn. Hydrogen gas. 2, it is used as a reducing agent. A reducing agent. And this reducing agent, they are agents that give off or release electrons. So they reduce, they give off electrons. That is this reducing agent. Okay, so those are the physical and chemical properties of an acid. If you have any question of hydrogen, sorry. If you have any question, you are let me. Thank you. So now we look at how this the hydrogen gas can be used. How do you use the hydrogen gas? What is it used for? 1, is used in filling balloons. It is in filling balloons. 2, is used as a reducing agent. As I explained earlier on, the reducing agents are electron donor. So they donate these electrons. Then 3, they are used for the production of oxygen hydrogen flame. Oxygen hydrogen flame, a combination of oxygen and hydrogen. Okay, so that is for the reaction when an acid reacts with a metal, then you have hydrogen gas being produced. Now, the reaction between an acid and a bicarbonate or carbonate to give off hydrogen gas, we'll look at how this hydrogen gas, carbon dioxide gas, is produced in the laboratory. So, laboratory preparation of carbon dioxide. Now, it's just like the laboratory preparation of the hydrogen gas, just like that one. The same apparatus, but the only difference here is that we still have the concentrated hydrochloric acid, but over here inside the flat bottom flask, you have a limestone, that is calcium carbonate. A carbonate, this one there, also marble and water as their mixture. It undergoes the same process whereby the concentrated acid is added to the calcium carbonate. Then the gas that is produced when the carbonate reacts with an acid is collected through the beehive to the gas jar. Now with this one, the gas is collected over water, as you said, or the downward displacement, or upward displacement of air. So have the equation there. We've already established this equation long time ago. Now, when this gas is collected into the gas jar, how do we test whether the gas is carbon dioxide or not? Now, with the earlier one, with the hydrogen gas, we used a glowing splint to detect or confirm the presence of hydrogen gas, giving a pop sound. But with this one, lime water is added, or the gas is passed through lime water. Now, the moment this lime water turns milky, it looks milky in nature, it detects or tells you the presence of carbon dioxide gas. So note these two important details. With the detection of hydrogen gas, a glowing splint is passed through the gas. Then when it gives a pop sound, pop, then it detects the presence of hydrogen gas. But with the one with carbon dioxide, when it's passed through lime water and the lime water turns milky, it indicates the presence of carbon dioxide gas. So these are how these gases are prepared in the lab. We'll also look, if you have any question, you can ask. We'll look at the differences between the physical and chemical properties, of the carbon dioxide gas. So physical properties of this carbon dioxide gas. One, like the carbon dioxide, like the hydrogen gas, it's also colorless and odorless. Colorless and odorless. Two, it is dense in water. In water, it looks heavier in water. Then three, it is fairly soluble in water as compared to that of the hydrogen gas. Fairly soluble in water as compared to that of the hydrogen gas. We look at the chemical properties of the carbon dioxide gas. One, it does not support combustion, so it does not support burning. Does not support burning. Two, it dissolves in water to form a weak acid. When they're fairly dissoluble in water, you have a weak acid as hydrogen triosocarbonate 5 acid, H2CO3, for that compound being formed. Now three, it turns lime water milky. Turns lime water milky. Then four, it reacts with carbon dioxide. Reactive metals react with this carbon dioxide to remove oxygen. So these are the chemical properties of the carbon dioxide gas. Then these are the physical properties of the carbon dioxide gas. So do note these two differences. If you are asked to give properties of the carbon dioxide gas, you can mix all of them together. But if you are asked the physical properties, then you stick to this one. If you are asked the chemical properties, then you stick to this. Then you are okay. Okay. So let's look at the uses of this carbon dioxide gas. What is it used for? One, put in fire extinguishers to put out flames. So this carbon dioxide gas is the one that is used in fire extinguishers to put out flames. Two, responsible for the rising of baker dough. So with the presence of this yeast, carbon dioxide also helps to make the dough rise. Then three, is used to preserve fruits. Used to preserve fruits. When you go to this big industry, that is what they use. Then four, used as a refrigerant. Used as a refrigerant. So this refrigerant, you would have the word refrigerate coming from it. So you should understand what the statement means. Then the last one, green plants require this carbon dioxide gas to prepare their food during photosynthesis. So an essential component of this carbon dioxide here is that this green plant require it to prepare their food. Okay. I'll still stress, if you have any question, you can ask and I'll attend to you. Okay. Now let's look at the basicity of an acid. Basicity of an acid. That doesn't mean that an acid is a base, but rather it tells you the number of replaceable hydrogen ions that can be replaced in an acid. Now, this basicity of an acid is the number of hydrogen ions. The number of hydrogen ions that can be donated by each molecule of an acid. So you have HCl. The number of how many hydrogen ions can be donated by the HCl? 1, because it has 1 hydrogen ions there. H2SO4. It has 2 hydrogen ions there, meaning that it can donate these 2 hydrogen ions there. But there are certain situations whereby the basicity of an acid is not, it doesn't depend on the number of the hydrogen atoms that is contained in the acid. It doesn't depend on the number on the acid, especially this inorganic acids. Now, let's look at an example. HCl has a basicity of 1 because it has only just 1 replaceable hydrogen ion here. But look at it, ethanoic acid, that is H3COOH. When you count, you notice that it has 4 hydrogen atoms inside the compound. But the basicity of this one is not 4, but it's just 1. Why? Because only 1 of this is released. Now remember, this ethanol here, or ethanoic acid, is a weak acid. And all weak acid, they partially ionize in solution. So they release just a few, meaning that they find it difficult to release these hydrogen ions or release protons. So here, because it's finding it very difficult to release these hydrogen ions, it will just release only 1. So the basicity of this one is 1, not 4. Now let's look at a table telling us this basicity of various acids. So the first one, you can see HCl there. It has just one H here, hydrogen atom here. So the basicity is 1. 2, you have H2SO4. It has 2 molecule of hydrogen here. So basicity is 2. H3NO4 and HNO3. It has just 1 of the hydrogen, so basicity is 1. Then H3PO4. It has 3 molecules of this hydrogen atoms, so basicity of what? 3. Now over here, look at this one. HCOOH, also a weak acid. It will struggle or find it difficult to release the hydrogen ion, so it will just release just 1. So the basicity of this compound here is 1. The same thing applies to this ethanol, CH3COOH. It will just release 1, or to ionize to release just 1. Then the last one, you have H2CO3, even having 2 molecules of hydrogen here, so the basicity here is 2. So reflect upon what I've shown you here. If there's a question, you prompt me. If there's no question, then I move on to the last aspect of today's lesson. Okay, so let's look at sources of acid. Where will you get these acids from? Where are these acids normally found? These sources of acids. Now, acids can be classified based on the source from which they are derived from, as 1, organic acids, and 2, mineral or inorganic acids. So based on their source, acids can be classified as organic and inorganic or mineral acids. Now, what are these mineral acids? The acids that are obtained from mineral sources. or these inorganic acids, they are ones that are obtained from these mineral sources. So HCl, H2SO4 are mineral acids. Then the organic acids are those that are obtained from living things and their sources. Living things and their sources. So they are usually natural in nature. Usually natural in nature. The only inorganic, um, you can say they are synthesized. They are usually prepared in the lab. Now we are going to look at how these organic acids look at their acid and where they are gotten from in a tabular form. So you have your acid on the left and the source of this acid on your right. So the first acid, we have the citric acid. Citric acid. And where would you find the citric acid? In citrus fruits. Citrus fruits. So orange, lemon, lime, they are all citrus fruits. Then two, butanoic acid. Now they are found in butter, cheese. So the acid that is found in this cheese and butter is the butanoic acid. Number three, tartaric acid. Tartaric acid. So these are the acids that are found in grape. So grapes, the acid found in grapes is the tartaric acid. Four, acetic or ethanoic acid. Acetic or ethanoic acid. Then a natural component of this acetic or ethanoic acid is vinegar. 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 Then five, you have lactic acid. Lactic. So the lactic tells you that the source is from milk or sour milk. Let me use sour milk. The next one, palmitic acid. So as you can see from the word palmitic acid, the source is palm oil. The next one, oleic acid, also gotten from olive oil. Then methanoic acid or methanoic acid, that is gotten from bee and ant. So when they sting you, what they inject into you is the methanoic acid. Now this methanoic acid causes a reaction or reacts with the skin, giving you a form of irritation. So you start itching your skin. What you itch there is the methanoic acid that has been injected into you. Then the last but not the least, you have malic acid found in apples. Then our last one is the ascorbic acid, more or less like the citric acid, which is also found in citric fruits. So these are all sources of organic acids that we can find ourselves. So if you have any question, this one ends our class today. If you have any question, you prompt me, then I answer them for you. In the absence of any question, the slides we made available for you to also read and understand. And should in case you have any question, you can write the questions down. In our next lesson, then you ask the question, then I answer you. I wished I could have given a trial work, but I don't know whether time would. Okay, so a minute. Okay, it look my the it will look. Okay, so let me read out. A mistake being made. The compound contain uh, vinegar is added to I blue litmus paper. What would you observe? That is a question A. What would you observe when vinegar is added to? Then I blue litmus paper. I powdered marble. Into brackets, you have calcium triisocarbonate 4. Calcium triisocarbonate 4. Then B, you have from A above, deduce the compound contained in vinegar. In A, or from A above, deduce the compound contained in vinegar. So I don't know whether my time is fast spent that you would present it in our next class, or we are presenting it now. Okay, so let's say we have 10 minutes more, so I'm waiting for responses from I'm waiting for the responses, the answers from each and every one of you. So what will you observe when vinegar is added to blue litmus paper? I powdered marble. Then from A above, deduce the compound that is contained in vinegar. So 5 minutes. Yeah, 5 minutes. So your time starts now. If you could please number the answers so that it doesn't mix up. So Sparky, if you can hear me, I've gotten your answer. That is, I'm guessing. I To me, I know is the answer is for the first one. That is, what happens when it's added to a blue litmus paper. To me, I know, but number it so that it explains what you're trying to answer. So you have 2 minutes more. 2 minutes more. Okay, that. Now you're now numbering it. That's nice. So a minute more. Okay, I've gotten an answer from Petra. Okay, time's up. Time's up. Now let's try and answer. Those who are able to answer, you have done well. Okay, Lisa. Lisa, have your answers. Okay, okay, Lisa, your answers are more detailed, than the others. Okay, so let's see whether we are right or we are wrong. Now the question says that what would you observe when vinegar is added to? So the first question you ask yourself is that what is vinegar? What is it? And what will come in mind that is a source of is one source of an organic acid. So you know that vinegar is an acid. Then you come, when it reacts with a blue litmus paper, then you go back to the properties of an acid, whereby we said it turns blue litmus paper red. So over here, when vinegar is added to blue litmus paper, it will turn red. So the answer is that the litmus paper will turn red. Then I is that what would you observe when that vinegar, the acid, is added to a powdered marble, calcium triisocarbonate 4. Now this calcium triisocarbonate 4, or the powdered marble, you know there is having this carbonate compound. And in the reaction or the properties of an acid, we observe that anytime an acid reacts with a carbonate, carbon dioxide gas is released. So over here, carbon dioxide gas is released. Carbon dioxide gas is released. It is not formed, but it is rather released. Then the last one, from the reaction above, deduce the compound contained in vinegar. Deduce the compound contained in vinegar. Yeah, indeed, it contains this acetic acid, but the main key word there that you would have, or the main key components that you can put there, is that it contains an acid. That's all. So the main compound here is an acid. The main compound here is an acid. So thank you very much for your responses. God willing, next week we'll continue. We'll pick up from there. Thank you. If you have any question, you can let me know. Thank you.